For this exam 2021, if you look to the problems, we have 5. In this exam, this practice exam, we have 5. Sometimes we have 6. So, first question. I have a lamp at point C. This lamp has a weight equal 15 kilonewton. So the weight here equal 15 kilonewton. This weight is supported by 2 cables. CA, so I should expect a force called the CA, and another cable CB, so I should expect a force called the FCB. So if you would like to draw the free body diagram at point C, I will have vertical weight 15 kilonewton, and I will have a force here in this direction FCA with angle 60. Keep in your mind, don't be confused. This angle 60 equal to this angle 60. And we have another force here, FCB with angle 45 degree. Keep in your mind, this angle 45 degree is equal to this angle. This one equal to this one. So this system of loading is in equilibrium. Electric light fixture is in equilibrium. We need to figure out the forces FCA and FCB since we have 2D dimension problem. I will apply summation f of x equals 0 and the summation f of y equals 0. To do this, I have to break each force to 2 components. Let's start with FCA. With this angle 60, I can break this force to 2 components. One horizontal FCA cosine 60, one vertical FCA sine 60. This one will be positive. This one will be positive. What else? I do prefer to sketch. Sketch more, you will have less mistakes. We have FCB with this given angle 45 degree. I can break it to 2 components. One horizontal and one vertical. The horizontal one will be FCB sine 45 degree. The vertical one will be FCB cosine 45 degree. Keep in your mind, this direction is positive, but this direction is negative. We have one more. This vertical weight, which is 15 kilonewton, in a vertical direction, in the negative direction of y. We don't have horizontal direction. Then I can apply summation of all forces in x direction equals 0. We have this one. We have this one. And we have this one. So FCA cosine 60 minus FCB sine 45 degree plus 0 equals 0. Summation f of y equals 0. We have this one, we have this one, and we have this one. So I have positive FCA sine 60 plus FCB cosine 45 degree minus 15 equals 0. This is the first equation. This is the second equation. I can solve them together to find out your unknowns. So if you would like to solve your equations, I will simplify the first one. FCA cosine 60. Cosine 60 is 0.5. So I have 0.5 FCA minus sine 45 degree. So I have minus sine 45 degree is 0.71 FCB. Is it correct? CB equals 0. From this equation, I can say FCA will equal 0.71 divided by 0.5 FCB. What I did, I moved this term to the other side. It will be positive. And then divided by 0.5 to find FCA as a function of FCB. Go ahead and simplify the second equation. FCA sine 60 is 0.86. 0.86 FCA plus 0.75 FCB. 0.71, I'm sorry, FCB. Minus 15 equals 0. I can remove this term and put this equivalent term. So 0.86 times 0.71 divided by 0.5 FCB plus 0.71 FCB minus 15 equals 0. The only unknown in this equation is FCB. I can figure it out. It will be 7.7. If you go back and put FCB equals 7.7, I can find the value of FCA. It will be 10.9. These are the two forces in the two cables, CA and CB. CA and CB. Try your best to sketch each force and find the two components. Try to do your best to write the two equilibrium equations and set up the two equations. You have to solve the two equations together to find out the final unknowns. This is the first question. Any question regarding this one? The second question. We are given three forces in two dimensions. We're still in two dimensions because we have X and we have Y only. We don't have Z. We are given three forces, F1, F2, and F3. But looks like F2 is given, F3 is given, but F1 is not given. The angle theta and the value of F1 are not given. And we are given also the magnitude and the direction of the resultant force. The resultant force is given. So first of all, this system is in equilibrium. Not in equilibrium. Not in equilibrium. But this system, the resultant force is given. So this is module number 1. I will start to break each force first to two components. If you start with F1, is not given. Angle theta is not given. That's fine. Keep going. So I will have F1 cosine theta and F1 sine theta. This direction is positive. This direction is negative. Looks good. What else? We have F2. F2 is given for 150. and we are given the angle 45 degree for F2. So I can break this force to two components, one horizontal 450 cosine 45 and one vertical 450 sine 45. The horizontal component will be 450 times cosine 45 give you 318.2 positive. This one also will be 318.2 positive. What else? What else? We are given F3 equal 200 Newton. You are lucky because F3 is given in X direction, which is positive, and nothing in Y. These are your forces. These are the three given forces, F1, F2, F3. We are given the equivalent, or the resultant, I'm sorry, the resultant. What is the X component of your resultant? What is the Y component of your resultant? You are lucky because the resultant force is directed along a positive X-axis only, and has a value equal 1000. That means the X component is positive 1000, and the Y component of the resultant is 0, because the resultant, the final resultant, is in X direction. So I can say summation Rx, the X component of your result, equals summation for all X component. So the X component is positive 1000. X component of the result equals summation of all X component of the forces. This one, and this one. F1 cosine theta plus 318.2 plus 200. So I can say F1 cosine theta will equal 881.8. I think I have a mistake, I believe. 1000 minus 318.2 minus 200. Yes, we have a mistake here. This one is 481.8. We have also the Y component of your resultant equals summation of all Y components of your forces. The Y component of your resultants is 0. Summation of all Y component, we have this Y component, we have this Y component, we have this Y component. So we have negative F1 sine theta, and we have positive 318.2, and we have 0. Then I can say F1 sine theta will equal 318.2. From this equation and this equation, I can solve them together to find out the F1 and the sine theta. It's very easy. Just to go ahead and divide the two equations. Divide this one by this one, equal this one, divide this one. Or this one divide by this one. So F1 sine theta divided by F1 cosine theta will equal 318.2 divided by 481.8. I can say this term will cancel this one, and this term equivalent to 10 theta will equal 318.2 divided by 481.8. It will be 0.66. If you got inverse 10 for your answer, your angle theta will equal inverse 10 for 0.66. Your angle theta will equal 3 33.4 degree. If you got your angle theta, I can go back here and put angle theta equal 33.4 to find out the value of F1. So sine this angle and divide 318 by sine. Your force F will be 577.4. So I found the value of F1. I found the value of theta for this problem. So these two questions related to module number 2, we have equilibrium. So summation of all forces in X equals 0, summation of all forces of Y equals 0. This one is module number 1, we forces in 2 dimensions, but we are given resultant. So the X component of your resultant equals summation of all Fx. The Y component of your resultant equals summation of all Y components. Any question? Do you have any question? We are looking in this problem for the resultant force and its direction for the given forces in 3D. We are given X, we are given Y, we are given Z. So it's the 3D. That means I need to break each force to 3 components to find out the X, Y, and Z component, then add them together. So F1 is given by 200. F2 is given by 300. F3 is given by 400. I can label this force by F4 and this one by F5. So let's start. I will start with F1. F1 is given with 3 angles, 60 degree, 60 degree, and 135. So F1 in X, F1 in Y, F1 in Z will be 200 cosine alpha, 200 cosine beta, 200 cosine gamma, all of them cosine, all of them cosine, all of them cosine. This is angle alpha, this is angle beta, this is angle gamma. Alpha, beta, gamma. So I can find out the 3 components for F1. 200 times cosine 60. This one give me positive 100. This one is positive 100 also. This one 200 times cosine 135 give me negative 141.4. What is the next force? For force F2. F2 is given in Z direction. So F2X, F2Y, F2Z. In Z direction will be positive 300. We don't have anything in Y. We don't have anything in X. For F3. Where is F3? Here you go. This one. So what is the F3 in X? What is the F3 in Y? What is the F3 in Z? F3 is given in the negative direction for X. So it will be negative 400. I'm sorry, negative direction of Y. So we don't have Y component, X component. We don't have Z component. What about F4? F4, F4X, F4Y, F4Z. F4 is given with 225 in the negative direction for X. So it will be negative 225, the x component. We don't have y component. We don't have z component. So far, so good. Then I need to look for F5. F5 is given with line, projection line. This is your projection line. So I need to break F5 between the projection line and your z-axis using the angle between the two green lines. What is the angle between the two green lines? 45 degrees. So I will write here 150 cosine 45, because this component is adjacent to the 45. And this one will be 150 sine 45. Then I will break the projection line component between x and y using the angle 30 between the two red lines. The x component is adjacent to the 30, so this one will be 150 cosine 45 cosine 30. This one will be 150 cosine 45. This is the projection line component time sine 30. So the value of f5x equal positive 150 cosine 45 cosine 30. The value of f5 in y direction equal negative, because this is the negative direction for y. 150 cosine 45 sine 30. F5 in z direction equal positive, because this is the direction positive for z. 150 sine 45. I can simplify these numbers. So 150 times cosine 45 times cosine 30. I got here 91.8. 150 times cosine 45 times sine 30. I got negative 53. 150 times sine 45. I got 106.1. I am done with the 5 forces, F1, F2, F3, F4, F5. Then I can get the resultant. The x component of your resultant, summation of all x components. So we have positive 100. We have 0. We have 0. We have negative 225. We have positive 91.8. All x component. Y component of your resultant, summation of all y components. We have positive 100. We have 0. We have negative 400. We have 0. We have negative 53. Z component of your resultant, summation of all z components. We have negative 141.4. We have positive 300. We have 0. We have 0. We have positive 106.1. What are these values? 100 minus 225 plus 91.8. I got negative 33.2. 100 minus 400 minus 53. I got negative 353. Negative 141.4 plus 300 plus 106.1. I got 264.7. So your resultant equal square root for 33.2 square, 353 square, 264.7 square. Your final answer will be 442.5. This is the value of your resultant. We have three angles for this resultant: alpha, beta, gamma. Alpha, beta, gamma will be inverse cosine, inverse cosine, inverse cosine. Inverse cosine for your Rx, divide R. Inverse cosine for your Ry, divide R. Inverse cosine for Rz, divide R. You have everything. Rx is negative 33.2. R 442.5. Ry is negative 353 divided 442.5. Rz 264.7 divide R 442.5. So alpha, beta, gamma will be, I can give you the final answer to make check. So inverse cosine negative 33.2 divided by 442.5, I got 94.3 degree. Inverse cosine for negative 353 divided by 442.5, I got 142.9 degree. Inverse cosine for 264.7 divided by 442.5, I got 53.2 degree. This is your resultant. This is your three angles, alpha, beta, gamma for this resultant. This is how to solve this kind of problem, 3-dimension, and you are looking for the resultant and the three angles. Question number 4. Question number 4. I will guide you in question number 4 to skip it to question number 5. Keep in your mind, we are given a weight. This weight equal 1000 Newton. Is hanging at this position using three cables, AB, AC, and AD. This system is in equilibrium. We need to figure out the force in cable AB, the force in cable FAC, the force in cable FAD. So we need to convert each force to three components. Keep in your mind, for 1000, the X component will be 0, the Y component will be 0, the Z component will be negative 1000. This is the most easy one. To figure out the coordinates, the three components or the three components for each force, we need to figure out the 2 points that each force is passing through. This is your X, this is your Y, and this is your Z. So point A will be 0, 0, 0. We are good. What about point B? Point B, if you would like to move from this origin to point B, I will move in X negative 1. I will move in Y positive 1.5. I will move in Z 3. For point C, if you would like to move from the origin to point C, I will move in X, how much? This one, negative 1. I will move in Y back, negative 2. And I will move in Z, this 2, positive. For point D, if you would like to move from the origin to point D, I will move in X, negative 3. I will move in Y, negative 4. And I will not move in Z. So negative 3, negative 4, 0. Once you can figure out the coordinates of 2 points related to each force, I can break FAB as a vector. I can break FAC as a vector. I can break FAD as a vector. And we have the weight as a vector. By the end, I can say summation of all x component equals 0, summation of all y component equals 0, summation of all z component equals 0. To set up 3 equations with 3 unknowns, I can solve them together to find FAB, FAC, and FAD. We solved many problems in this way. The most critical step, how to figure out these coordinates correctly. And I'm giving them to you. The last problem that I will solve to the end, we are given a beam rigid body and we are looking for reactions. A is hinge. So I have 2 reactions at A, YA and XA. B is roller. So I will have only 1 reaction at B, YB. We are given a distributed load, which is rectangle. This rectangle will have an area equal 40 times 8, and the centroid will be at the midpoint. So your equivalent will be here. 40 times 8 will be 320. And this distance will be 4, and this distance will be 4. We are given a moment, 150. And we are given a force which is inclined. So I have to break it to 2 components, 1 horizontal and 1 vertical. The horizontal one will be 20 times 3/5. The vertical will be 20 times 4/5 using this right angle triangle and these 2 angles. So this value will be, I think, 16. This one will be, I think, 12. If you would like, I can redraw the beam one more time to be more clear. I have reaction here, XA, reaction here, YA. I have reaction here, YB. I have equivalent here, how much? 320. I have vertical force here, 16. Horizontal force here, 12. And we have given moment here, 150. Keep in your mind, this distance is 4, and this distance is 4, and this distance is 3. Then I can apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Let's start. All forces in x direction equal 0. I have positive XA. I have positive this 12. Nothing else. Equals 0. So XA will equal negative 12. Negative means you assumed the wrong direction. This XA should be to left, not to right. Don't change anything on the sketch. Just give me the correct direction beside your value. Summation f of y equals 0. I have positive YA. I have negative 320. I have positive YB. I have negative 16. This vertical force, this vertical force, this vertical reaction, this vertical reaction equals 0. I can make simplify. YA plus YB will equal 336, I think. The third equation, summation moment. I do recommend to take moment about point A with the highest number of reaction. I do recommend to assume the clockwise rotation is my positive. Everybody, please pay attention. I will ask you a question and I need answer. XA will be multiplied by distance. YA will be multiplied by distance. 320 will be multiplied by distance. YB will be multiplied by distance. 12 will be multiplied by distance. 16 will be multiplied by distance. 150 will be multiplied by distance equals 0. I have to list everything in your problem in this equation. XA, Y8, 320, YB, 12, 16, 150. Everything must be listed. I am sitting at A. What is the distance between XA and A? 0. What is the distance between YA and A? 0. What is the distance between 320 and A? 4. What is the distance between YB and A? 8. What is the distance? This is the first question, and I need one to answer my question. What is the distance between point A and 12? Your 12 is located here. So what is the distance between the two locations? To multiply 12 by. Any help? Guys, are you still here? David said 0. Why? Why it's 0? It cannot work 4 plus 4 plus 3. We have 9. I'm sorry, we have 11. Why 0? 0 is correct, but why? Thank you. 16 will be multiplied by 11. Why? The two forces are at the same point. Why one of them is multiplied by 0 and the second one is multiplied by 11? Because your force and your distance must be perpendicular. Since 16 is vertical, so I can multiply it by 11 meters. But 12 is horizontal. If 12 is horizontal, what is the vertical distance? We don't have vertical distance between this point and this point. That makes sense? So don't be confused. Second question. What is the distance for 150? We have a moment here, 150 at this point. So what is the distance between 150 and the point A? Any help? What is the distance between the 2 points? Is it 0? Is it 11? Is it what? Any help? At the same point, 12 does not have distance vertical. 16 has a horizontal distance 11. What about 150? Any help? This is the last question. The distance does not matter. No, it's not one. It's not. We don't need distance. This is the correct answer. We don't need distance. So you have to put 150 only without multiplying it with any. Why? Because this is a moment. If you are given ready moment, you don't need distance. If you have a force, we still need distance. If you have a force, we still need distance. But if you have a moment, does not need distance. Then I don't care about this sign. I don't care about this sign. 320 will be positive. YB will be negative. I don't care about the sign. 16 will be positive, and the 150 is given clockwise. It will be positive. The only unknown in this equation is YB. So I can figure out the value of YB. It will be 320 times 4 plus 16 times 11 plus 150 divide 8. I got 200.75. Go back here and put YB equal 200.75. Then I can find the value of YA. It will be minus 336, 135.25.